Welcome. So we have seen what is a derivative, how to find derivatives. We have also used some examples to find derivatives, and you also now know that not all the functions can be differentiated. So it's not practical, it's not easy for us to be finding the derivative of a given function using the definition. It's a lengthy process. So there are some rules that they're going to give us always the same result that we would have if we're using the derivative from its definition, which involves limit. So in this video we're only going through 3 of those rules. So rule number 1, the derivative of a constant. Well, if f of x is equal to c is a function such that c is a constant, then f of x is equal to 0. What it means is that if you have a constant or a function that is a constant, then the derivative of that function, whatever the point you're going to choose, is going to be 0. So for example, you have to find the derivative of 3. Well, 3 is a constant, and if you take it from the perspective that the derivative means the rate of change, so if someone would ask you what is the rate of change of 3, well, 3 is a constant, doesn't change at all. So in this case, what we can say is that the rate of change, which can also be expressed as f dash of x, is equal to 0. How much 3 changes with respect to x? What is this rate? Well, 3 doesn't change at all because 3 is a constant. The next property is this you can apply for all the constants, like all the constants, both negative and positive, integer, all the real numbers. As long as they are constant, you're always going to get 0 because it's a constant, doesn't change. The second rule says derivative of a power of x. So if f of x is equal to x raised to n is a function such that n is a real number, then f dash of x is equal to n x minus x raised to n minus 1. What happened over here is that this n that was previously n only now is subtracted 1, and the previous n before the subtraction is taken to multiply the whole function now with that 1 subtracted from that n. So look at this example. We have to find the derivative of f of x, which is x squared. So in this case our n is 2, and the formula says that f dash of x is equal to n raised to x raised to n minus 1. So our n minus 1 is equal to 1. So this f dash of x is equal to, what is our n? Our n is 2 into x raised to n minus 1, because n was 2, 2 minus 1 is 1, so we have 2x. So imagine a different situation like this, that we have a cubic root of something. So if f of x is equal to cubic root of x, how to find it? Well, we need to know the properties of roots. So before we find the derivative of this function, we have first to try to simplify this. So we have f of x is equal to this. When you have something like this, this means you have x raised to power 1. So what we have now is that this can be represented as x raised to its power 1 divided by the index of the root. So we have x raised to 1 by 3. This 1 was from this side and this 3 came to this side. So now our n is 1 by 3. It's a way that now we can solve this function. So to find the derivative, what we do f dash of x is equal to, the formula says n, so you should multiply it by n, and our n is 1.3. So 1 divided by 3, into x raised to n minus 1. So into x raised to 1 by 3 minus 1. So f dash of x is equal to 1 by 3, which is our n, raised to x raised to 1 by 3 minus 1. This is our n minus 1. So our n minus 1 is equal to 1 by 3, which is n minus 1. So To make this, you can just use LCM. So this you put here as 3, and then what we have is 1 by 3 to x raised to 1 minus this 3 multiplies here, we have 3 divided by 3. So f dash of x is equal to 1 by 3 into x raised to 1 minus 3 is minus 2 by 3. Because this is negative, means that the representation of this may be as a fraction. So we have 1 divided by 3 into x raised to 2 by 3. But this situation I have here as for the properties of the roots is the same as we had in the beginning when we did this. So the final answer is 1 divided by 3 into cubic root of x squared. As you've seen here, what just happened is that the power of x increased from 1 to 2. And the last case, the derivative of addition or subtraction of a function of functions. If f of x is a function of x and g of x is a function of x, then f plus g dash of x is equal to f of x plus g of x dash. So this is the sum of two functions that both of them with respect to x, a function f and a function g. So to find the derivative of these two functions, when we add them or we sum them up, what we do is basically find the derivative of each individual function, and then we have our result. The same thing works for the subtraction. We have to find the derivative of individual functions and then subtract as the subtraction is ordered. If it's f of x minus g of x or g of x minus f of x, that is going to dictate how we solve in the order. So look at this. Given that f of x is equal to 2x plus 3 and g of x is equal to 5x, find the derivative of this is addition and this is subtraction. So how to solve this? Well, for the case A, we have f plus g dash of x. This is equal to 2x plus 3, which is our f, plus 5x, which is our g. All this is dashed. So we have this and this. They are summing up and giving us 7x plus 3. So now, what is the derivative of 7x plus 3? Well, to find the derivative of 7x plus 3, it is equal to the derivative of 7x plus the derivative of 3. Derivative of 7x, from the property we saw here, our 7x, our n has power, our x has power 1, which means our n is 1. And for, as the property says, we are going to have x raised to n minus 1. And this is going to give us n x raised to 0. Any number raised to 0 is 1. So this n was 1, and then we have 0. And because you're multiplying by a constant, this constant now does not enter into the integration. It's just there to multiply. That should be taken in mind always. It's not n. So as a result, what we have? We have 7 into 1 plus 0. So this gives us 7. Second case, f of x, f minus g. So f minus g dash of x is equal. Again, what we do, 2x plus 3, but now it's minus. All this we need to differentiate. So if you take these two, we had 2x minus 5x. What we have as a result is a minus 3x plus our 3. So again, the same rule. This x here is raised to some power of n, which in this case is 1, and n minus 1 is 0, which means this x is going to be powered by 1 by 0, and this gives us 1. So that 1 will be multiplied by this minus 3. So we have minus 3 into 1 plus the derivative of this constant is 0. So this becomes